Did you know that the state and strategy design pattern have the same class diagram, but they're used differently? To learn more about the strategy design pattern in Java, watch this video. So, the main differences are the strategies are passed to the context object as parameters, while states are created by the context object itself. Also, strategies only handle a single, specific task, while states provide the underlying implementation for everything the context object does. But what is the strategy pattern? Well, in strategy pattern, a class behavior or its algorithm can be changed at runtime. So, since each algorithm is encapsulated, the client can use different algorithms easily. It offers clients a choice of algorithm implementation through object composition, and remember, it's always better to use composition instead of inheritance, and this type of design pattern comes under behavioral patterns. Okay, next we'll go to Eclipse and take a look at an example of the strategy design pattern. So, here we can see an abstract class called athlete. There's some properties like name, age, active, and we have getters, setters, and one abstract method train. Next we have a basketball, which is extending the athlete and it is overriding the train method. Okay, so here we're creating a default constructor. We're going to move these methods inside the constructor, and here inside the train we're going to print a message that's typical for the basketball, like let's say bowling, just this. Let's go to the tennis class and we are going to do the same. We are going to move the methods inside the constructor. So let's say public tennis, and here we're going to move these methods inside, and we're going to give a message here that's typical for tennis, or it would be typical, for example. So let's just type tennis. Okay, so we are ready with the tennis, basketball, and athlete. Now, if we were to go and create a new class, let's say it would be a boxer, and this boxer has a new properties. So first we'll go and extend the athlete class, but then this boxer can fight, and we need to first go and implement the train method. But this boxer can fight, and how would we go and approach this? Where we are going to put this method with fighting? So let's think. If we come here in the base class, the abstract class, we can just go and say public, then we're going to say string and fight. Okay, well, that's nice. Let's return a string message. So we're just going to say return fight, right? Okay, whatever it is. So this is possible. It's based on the object-oriented principles of inheritance. However, it's not very good practice, because inside of the boxer class we'll have access to this method. So let's just go first and create a constructor for the boxer. So once we create a constructor, we can call some methods that are based inside the athlete class. So here we can call the fight class, which is alright for us, but it's not good because we have access from basketball and tennis classes as well to this fight method, and these types, they don't support fight. They cannot fight, for example. So the algorithms are not supported here. They're not available here. So what do we need to do? Well, we can just go and we can call this from the basketball or from everywhere. And you might say, we can just go and override this method that's inside the basketball. So we'll give him a property that he's not able to fight. So we'll just say public string fight and then return a new message like cannot fight actually, for example. And this is possible, but it's not a good practice. It's based on inheritance, but it's much better to have composition whenever possible rather than inheritance. So here we can see the person cannot fight, but it's overriding the method. So it's possible, but it's not a good practice. So let's just remove this. We'll go to the athlete class, and here what we are going to do, let's just remove this method. And what is the good principle? So we don't have the fight anymore. Another approach would be we'll go and create a fight method inside the boxer, but let's say we will have a new class, wrestler. So this wrestler, he will have the same properties, fight as well. And you see, okay, so the boxer and the wrestler, they have the fight method, and the basketball and tennis, they don't have the fight method, so everything is okay. But it is not. And why? Because we have fight method in boxer and we have fight method in wrestler, so we can just copy and paste this, and we can have 5-10 more classes like kickboxing, judo, karate, and so on. And let's say the requirements change and you need to go and change this fight method in every and each one of them, so this code will be very hard for maintenance and this will be a nightmare. So this doesn't solve our problem quite well, so we'll need to go and use the strategy design pattern. So let's remove this from our boxer class, and what we are going to do? Well, we'll go and create a new interface. So let's just go create new interface and we are going to call it fighting. Okay, and inside this interface we will have an abstract method. So this method is going to be fight or fighting or whatever the name is. However, the idea behind this method and this interface is that we'll have two base classes. We'll have one class that's responsible for can fight. Okay, let's create it. Then we're going to implement this interface and override the method. So each class, like boxer, wrestler, and so on, that can fight is going to have a concrete implementation of can fight, and each one that doesn't have will have a concrete implementation of cannot fight, which we'll create in a second. So here we override this method and we'll say something like return string, which will be yeah, I can fight, do you have a problem or something. So this is something that's quite common with the people that can fight. So let's go and create a new class. So this class is going to be called cannot fight, and it's going to implement the fighting interface as well. However, we're going to override the method not to be able to fight. So let's say implements fighting. Okay, let's add the method, and here we're going to return the new message. So the message will be for someone that's not able to fight, or the idea here is not about fight, not fight, it's about the algorithms, what the method are able to do. So you have a certain amount of classes that do some functionality and the others that and the others that do not do this functionality. So we need to make a distinguish adjustments between this. So next we are going to create a public variable of type fighting and we are going to call it fighting. Okay, after this we are going to create a method public and we are going to say here string try fighting, and here inside this method we are going to call fighting.fight. So let's go and do it. Okay, and after this we are going to create a method for setting. So let's return this fighting.fight, and we're going to say here public, and then we're going to say void set fighting, and inside, instead of giving string, boolean or integer, we are going to give a variable of type fighting, and we are going to set this variable here. So with this try fighting and set fighting and the instance of fighting interface, we are working with composition instead of inheritance. So let's go and create a new football class. So here this football is going to extend the athlete. Okay, so let's extend athlete, and we will need to go and add the method which is train because it's abstract method. Now we'll go and create a constructor, so public football, and inside we are going to instantiate some data. So we'll go and say set. Okay, and we'll use the set name. So let's just set the name of the person with Ronaldo. Okay, and after this we're going to set the fighting. So we'll do this in this way: fighting equals new cannot fight. So here we're doing this in Okay, let's copy this and we are going to paste it inside the basketball and tennis, because these classes are not able to fight, and this doesn't need to be fighting. It could be any logic, any algorithm, so you have one set of classes with one functionality and another with a different one. So we're in the boxer and here we have fighting equal new can fight. Okay, and we are going to do this for the wrestlers because they can fight or they have this functionality as well. Now what we need to do, we'll go and create a new class which is going to be called test athletes with the main method, and here we're going to create objects. We're going to create an object of type boxer, wrestler, football, tennis and basketball. So we're going to create these objects, but they will be of type athlete. So we will say athlete Ronaldo equal new football, and then we will say athlete and then of type basketball, tennis and boxer and so on. So the beautiful thing here about the strategy design pattern is that we can create a type of football, tennis or whatever type it is, and this type doesn't have the functionality of fighting or our algorithm or whatever algorithm. However, we can modify this at runtime. We'll be able to go and say Roger.setFighting and he will learn how to fight, or Roger or whatever your class can learn how to do something during runtime, and this is very beautiful. Now let's go and we are going to have a few print lines and see what the output is going to be. So remember, we have the three classes that extend from athlete like football, tennis and basketball that are not able to fight, and we have two that are able like the boxer and wrestler. Okay, so let's go and say Ronaldo try fighting, and then we'll do this for the rest of the classes. We'll print the try fighting method of each object. So the good thing about this strategy design pattern is that it's much easier for you to go and add new functionality, because we can go and add new types. We can go and add a kickboxer, a judo, a fighter, street fighter, brawler, whatever, or we can go and add new classes. Let's say we have football, basketball, we can go and add new ones. So we can say volleyball, we can say a lot different new classes. So we are almost ready with the print statements, and let's see what is going to be. Let's just correct the name of the objects. Okay, instead of Roger and Tyson we will put the right ones. Okay, and we will see that we will be able to go and configure some of the objects during runtime, which is very nice. Okay, we are almost ready and we're on the last one, wrestling star. Let's see, Karenin. This was one of the best wrestlers. I think he has only 2 losses. Okay, so let's save and run this. Save boxer. Okay, so we can see the input here. Let's just make it look a bit nicer. Put a new line. Okay, run it again. So we can see the first 3 lines is football, tennis and Jordan or basketball. So it's they cannot fight and no worries. But then the last 2, they are fighters and they can fight. However, let's say we have Roger, who has been training with Mike Tyson, and Mike Tyson is able to teach him how to fight. So what can we do? Well, do we need to go and create a new tennis object? Well, no, we don't. You can see how we will be able to do this very easily. So we print again Roger try fighting, but first we need to go and say Roger set fighting, and we're going to set with new and then say can fight. So we set the capability of Roger with can fight, and then we can print and see that Roger is able to fight after trained by Mike Tyson. Okay, we can do the same with another object. Let's say Michael Jordan is training with Karenin. Let's say Jordan.setFighting, and again we use new can fight. Okay, and we will print the line and see that Jordan is able to fight. And this can work in the opposite direction as well. We can take some wrestler and then unteach it how to fight after 20 years not training in the gym, you know. So this functionality is very powerful during runtime. And Ronaldo, we cannot teach him how to fight, unfortunately. Okay guys, thanks for watching. Make sure you hit the like button, don't forget to subscribe to the channel, and see you in the next video.